What is ABG? Arterial blood gases. It measures the amount of gases present in your blood, and it's usually measured with the help of 1 pH, 2 carbon dioxide, and 3 the amount of bicarbonate. pH, it tells you how acidic or alkaline your blood is, and the normal value is 7.35 to 7.45. So this is the normal value. Anything below it is acidic and anything above it is alkaline. Okay. Next is carbon dioxide. It is controlled by the lungs. The amount of carbon dioxide in your body is directly proportional to the hydrogen ions in your body, which is the acid. So carbon dioxide, you should relate it to the acid. So more the carbon dioxide, more acidic your blood is. Next is bicarbonate. Bicarbonate is the base, so you can remember it because both starts with the letter B. Yes, and the normal value is 22 to 26, and bicarbonate is controlled by the kidneys. So kidney means metabolic and lungs means respiratory. So base, kidney, bicarbonate, and acid is the carbon dioxide. So the kidneys and the lungs, they work hand in hand together to maintain the pH of the blood between 7.35 to 7.45, which is the normal range. Okay, so this is what they do. They work together to maintain the pH. Now this is done in 3 steps. First, we see whether it's acidosis or alkalosis by seeing the pH, whether it's high or low. Second, respiratory or metabolic by seeing the carbon dioxide and bicarbonate levels. And third, we look at whether this is compensated or uncompensated. Now let's solve some questions. On the left side, I have the normal values, and the question will be on the right side. pH 7.25. You can clearly see that it's less than normal value. Carbon dioxide 51 and bicarbonate is 25. Okay, so any value of pH which is below 7.35 is acidic. Acidic, so your blood is acidic. Next, we look at the carbon dioxide, 51. That is much higher than the normal range because the normal range here is 35 to 45 and this is 51. So there's a lot of carbon dioxide, increased carbon dioxide, which means increased acid. And we know carbon dioxide is controlled by the lungs, so it is respiratory condition. So respiratory. Next, we look at the bicarb. It is within the normal range, 25. It's between 22 and 26. So we can conclude that this is respiratory acidosis. Next question, pH is 7.6, carbon dioxide 29, and the bicarbonate is 22. So pH of 7.6 is high. So that is towards the alkaline side. Carbon dioxide 29 is less than the normal range and bicarbonate is within the normal range, which is 22. So alkalosis, we can write that down, 29 is less. So anything that is high or low is abnormal. So here we have respiratory alkalosis. Next question, pH is 7.25, carbon dioxide is 36 and bicarb 21. pH is low, 7.2 is less than 7.35, so it's acidosis. Carbon dioxide is within the normal range, 36, but bicarb is low, 21. So anything is low or high, abnormal, so it's metabolic because it's bicarbonate. So it is metabolic acidosis. Fourth question, pH is 7.56, carbon dioxide is 41, bicarb is 31. Since the pH is high, 7.5, it's alkalosis. Yes. Then let's look at the carbon dioxide. It's normal, it's within the range of 35 to 45, it's 41. Bicarb is high. So here it's a metabolic condition and thus it is metabolic alkalosis. All these cases or questions were of uncompensated acid-base analysis. Next, we need to see what is compensated cases. Compensation means trying to fix the problem. Okay, compensation is trying to fix the problem. This can be fully or partially compensation. So if there's a problem with the respiratory, that is that if the carbon dioxide is abnormally high or low, then the metabolic will step in and try to fix this problem by increasing or decreasing the bicarbonate. If high carbon dioxide is there, then the body will increase the bicarb to compensate for the increased acidic state of the body. If we have a metabolic problem, then respiratory will come to fix it. For example, if there's low bicarb, or let's say there is high bicarb, then the carbon dioxide, that is the respiratory, will increase itself to increase the acids in the body because the base is so high. So to compensate, it tries to increase. Next question, pH is 7.5, carbon dioxide 51 and bicarb is 41. pH is high, so alkalosis. Now carbon dioxide is also high because our normal range is 35 to 45. Bicarb is also high. Everything is high. Right, what do we do? So alkalosis, we know that what is the pH. So we know that alkalosis means it's metabolic. So this means there was a high bicarb in the body and the body tried to compensate it by increasing the acid, that is a carbon dioxide. And we have to look at the pH now. pH is 7.5. That is not within the normal pH range. This means that the body was not able to fully compensate, and it was not able to bring it back to the normal pH, so it is a partial compensation. Next question, pH is 7.3, carbon dioxide is 50 and bicarb is 49. pH is clearly low, so it is acidosis. We know acidosis means respiratory. So because the body had high acids or high carbon dioxide, the body tried to compensate by increasing the bicarb, and that's why the bicarb is also low here. Okay, so increase carbon dioxide, body tried to increase the base so that the pH is balanced, so increase the bicarb. That is why it's 49. But now we have to look at the pH. The pH is 7.30. That is not within the normal range. Normal range is 7.35 to 45. So was the body able to fix the issue fully? No, it was not able to bring the pH back to normal. So it is a partial compensation. In this question, you'll see that the pH is 7.35, which is in the normal range. Carbon dioxide is 49 and bicarb is 30. Both are high. Okay, so now what do we do? When the pH is normal, how do we know if it's respiratory or metabolic? Yes, this is when you zoom in the pH value. That is, you write down 7.35, 7.36, 7.37, then 7.38, 7.39, etc. That is one set of limit. That is basically the lower limit. Second is 7.41, 42, 43, 44, 45. That is the alkalotic side. So we are basically splitting the range into two. The acidic side and the alkalotic side, lower half of the normal and the upper half of the normal. Now see where the pH is lying. 7.35 is in the lower half, that is the acidic side. So we can conclude that this is acidosis. So acidosis means we know the carbon dioxide is involved, respiratory. So this is a respiratory acidosis, and the body tried to compensate it by increasing the bicarb to 30 and tried to fix the problem. Now we have to look at the pH. That is 7.35. Is it in the normal range? Yes, it is. So it is fully compensated because the pH is normal. In full compensation, the pH is in the normal range. Let's do another question. pH is around 7.42. Carbon dioxide is 49 and bicarb is 36. Now look where 7.42 lies. Yes, it's in the alkalotic side. It's in the higher side, alkalosis. So alkalosis means we know it's related to the bicarbs. So because there was a high amount of base or bicarb in the body tried to compensate it by increasing the acids or the carbon dioxide. So this is a metabolic alkalosis. Now we have to look at the pH. pH is 7.42. Is it in the normal range? Yes, it is in the normal range. This means the body was successful in achieving the pH. So it is a fully compensated case. So I hope your confusion regarding the acid-base questions and the ABG analysis is fully rectified. If you enjoyed this video, please subscribe to my channel and do let me know in the comments what topic I should do next. Thank you.